Regression loss functions. In the last lecture, we learned about loss functions. Here we are going to specifically look at regression loss functions. What are the specialities that a loss function should have in order to handle a regression task? And what exactly are those loss functions? This is what we are going to look at. So first of all, what is regression? Let us be clear about this. What is a regression task? In machine learning, generally you will talk about regression task, classification task, and so on. You should first understand clearly what is a regression task, what is the requirement while you're training for a regression task, and accordingly you should think of what should be the loss function. Okay. First of all, when talking about regression, you should think of something like this. You are regressing back towards the average. That is, if you are given a data set, let us take a random data set. Let us say height of a lot of people from this generation. So if you take a lot of people, they'll have, this is the scale of height, let us say, a lot of points will be concentrated over the mean. Let us say this is some mean height of this particular generation. There will be some particular people who will be having larger height. Similarly, some people will be having smaller height. Then, if there is a person having a height, a very high height, let us say this person is having 8 or 7 feet height, if he's a very tall person, what do you think about the next generation? If this person is going to have a child, what about that child? Do you think this child will generally have a height larger than this or smaller than this? If you take someone from here, you can't really say anything. Let us say you're taking a person from somewhere here around the mean. Anything can happen. Generally, it can be a child who is having a larger height or also a child which is having a smaller height. But if you take the person who is the tallest among all these, generally, child will always be shorter. That is, there will always be a tendency to come back to the mean, that is regress back towards the mean. Always any data set will try to regress back to the mean and always it will try to reach the mean. Let us say a person is very short, he has a child, most probably the child will be taller than this person. The height will try to come back to the mean. This is why it is called as regression. So generally when you are handling a regression task, you want to compare the predicted output, which will be one particular value, with the expected output, and then you want to find the difference between these. And next time when the model is predicting, you want the prediction to be more towards the average value. This is the requirement. Let us say some particular parameters are provided, input parameters are provided. From this, the model want to judge some particular output value. Then we are expecting that this output value will be some sort of an average. So it's average is not the exact term. I'm using it so that you understand it. Okay. So whatever is the predicted average, this has to be compared with the actual output value that is expected, and then you want to find the difference. So the speciality of loss function should be something that can deal with these continuous values. That is, prediction will be generally like, let us say, house prices, or it can be temperature or stock price, something like this. So most of these will be a case of predicting a continuous value. This will be the task. What happens then? Your loss function should measure how close your prediction y cap. Why am I calling it y cap? Generally, you will say input is x and output is y. So x is the actual input, y is the actual output, then y cap is the output that is predicted by your model. When I said actual output here, I meant what is the actual target, what is the expected value. Your model was supposed to produce y when it was given x as input, but what it predicted is y cap. So y cap might be slightly differing from y. The next function is you have to identify a loss function L of y cap, which will find out how far is y cap from y and what adjustment is to be made. So the next question, automatically the next question in your mind is, why can't you simply say loss is equal to y minus y cap, because this will give you the difference. So if loss is taken as y minus y cap, you can clearly understand how far is the prediction y cap from y, and accordingly you can make all the adjustments. Then why is this not done, and why are we having special loss functions for regression tasks? This is what we have to understand first. So there are few things you have to keep in mind why it is not simply y minus y cap. First thing is, when you're having errors, there may be positive errors and negative errors. That is, let us take the height example itself. If this is the mean height, there may be some particular value here, some particular value here, while you are actually trying to predict some point which is at the mean. Let us say you are trying to predict one particular value which should be actually here, but one prediction was here and another prediction was here. If you are doing simply y minus y cap, first prediction this will be positive, second prediction will be negative. Negative in the sense the difference with the expected value will be positive and the second one will be negative. What happens then? In first case, your loss L1, let us say this value is 5, this value is 6 and this value is 4. First case, 6 minus 5 will be 1. Second case loss will be 5. So the second one will be 4 minus 5, which is minus 1. Then when you are adding up all these losses, L1 plus L2 will tell you 1 plus minus 1 equal to 0, which means your model made no mistake at all. But actually, both were mistakes. It should have been actually here at the center, but both the values were mistakes. What should be the actual way to handle then? You should handle in such a way that positive and negative errors should not cancel out. So this is one reason why you can't simply have y minus y cap and you should have a logical loss function. Second thing, why should you not use simply y minus y cap? Second thing is, loss must always be non-negative. And one more thing, ideally it should be differentiable. This is an important point. The reason it should be differentiable is you should be able to find the gradient, and that gradient is what actually you use in optimization algorithms in order to update the weights of the model. So one, we told positive and negative should not cancel out. Loss should always be non-negative. That is, your final loss should always be non-negative. It should be differentiable. Then what else is the one more thing is, when you have a mathematical value, loss or anything that you use in statistics, here machine learning is basically coming out of statistics. All these concepts are coming out of from statistics. So if you simply take a y minus y cap, it lacks that clear statistical meaning, or you can say a statistical objective of what you are actually going to do. So when we learn about loss functions, you'll come to see that each of the loss functions, they'll have a clear statistical meaning which will add more value to your loss function. So your fourth point is you should have a statistical meaning. That is one more point why you should not simply go with y minus y cap. See, I am explaining all these things because you need to understand why we have different loss functions. If it is a regression task, the simple question is, why can't you simply go with the y minus y cap? You should be clear with this, and then you need to learn each of those loss functions. Then it will add more clarity to you. Okay. And one more thing is, over prediction and under prediction should be penalized equally. So that is already covered here when we said positive and negative will cancel out. The same thing can be stated in a different way as over prediction and under prediction. Both of them should be penalized equally. So these are the main reasons why you should not use simply y minus y cap. Then what are the actual loss functions used for regression? They include, one is MSE, also called as mean squared error. Similarly, you have mean absolute error. Then you have RMSE. This is called as root mean squared error. Another one is you have Huber loss. So sometimes we'll call it as loss, sometimes we'll call it as error, but all are one and the same. Okay. Then you have log cosec loss. This is another loss function. Then you have quantile loss. All these are used for regression functions. That is, when you want to have a loss function for training for regression, all these are used. So in the coming lectures, we'll deep dive into each of these and understand what is the significance of each of those loss functions and where exactly you should use these loss functions. Okay, so this was an introductory lecture on regression loss functions.